What is time? We all think we understand it very well until someone suggests that we try to define it. That's when most of us realize we don't know what words to use to describe time. Worse still, the more we think about time, the more complex the topic becomes, and it tends to inadvertently evoke mystical elements that are often prevalent in science fiction works. Have you ever wondered about the essence of time? Science suggests that it is a linear dimension, while some perspectives argue that time moves in cycles or circles like the seasons in a year. Although many people in today's era seem to agree that time is linear, when we look at the historical existence of humanity, we see that time has a cyclical nature and changes in rhythm. Ultimately, what is the nature of time, and does it truly exist? This is the issue that we will explore and answer together in the upcoming video, Illusion of Time. Einstein once said in the theory of relativity decades ago, there is no unique and absolute time. The time that humans conceive of is only an illusion. In January 1989, to demonstrate this theory, NASA conducted an experiment called the Time Evidence. The experiment involved digging a cave several tens of square meters wide at a depth of 150 meters underground, adjusting the temperature, humidity, air, and living conditions inside to be identical to those on the surface. NASA adorned the room with utmost comfort and luxury, providing all necessary supplies: food, drinks, beds, wardrobes, tables, chairs, and household items. After a period of candidate screening, Fellini, a 27-year-old girl from Italy, was selected for the experiment. The notable difference in the cave was the absence of natural scenery outside, no changes, and no time-marking objects. Time on TV and computers was completely erased. From the moment she entered the cave, the participant would live in the dark basement without the need for work, except for eating and sleeping. She could freely entertain and relax as she pleased. This lifestyle appealed to many, attracting numerous volunteers who registered due to the attractive rewards offered by NASA. Foni, the participant in the experiment, is a designer who constantly faces a busy and exhausting life due to her job. She volunteered for the experiment, seeking a life without stress, with abundant food and drinks, and without the need to continue working. The controlled environment intrigued her, and Foni, with good physical health and well-rounded mental qualities, was excited to have surpassed 10,000 candidates to be part of this project. When asked how long she could stay in the cave, Follin confidently stated, "If given enough food, drink, clothing, and entertainment, I could stay there for a lifetime." From the monitoring screen, one could see Foni's cheerful smile upon observing the luxurious decoration in the underground room. The laboratory space was not large, only 18 square meters, but it was sufficient for Foni to live comfortably. NASA also announced that if she wanted to stop midway, she could press the doorbell to return to the surface earlier than planned. Initially, Foni seemed quite comfortable, eating alone, playing games, watching movies, and resting when tired. However, in less than 2 weeks, she started feeling bored. Foni decided to enrich herself by using this free time to acquire knowledge. However, because the room lacked a time display, her previous life routines were almost turned upside down. Foni needed to learn when to rest, when to eat, when to read, and when to sleep. She could only follow her instincts and what her body sensed, with the brain in control. After a while, scientists observed that Foni would only sleep for 1 hour, wake up to eat and read, sometimes sleeping for 2 days before waking up again. Her health deteriorated, and she often muttered to herself in a semi-conscious state, losing interest in her favorite foods or movies. Concerned for her health and safety, scientists decided to halt the experiment before things worsened. When brought back to the surface, due to being alone for an extended period, she struggled to adapt to the sunlight, experiencing stiffness in her body. Doctors reported that both her physical and mental health were severely compromised. Once Foni recovered, scientists asked her how long she thought she had been in the cave, and she believed it was 60 days. However, in reality, she had been there for 130 days. This serves as evidence that in a state of timelessness, humans find it challenging to regulate themselves. In reality, we can always rely on clocks to organize our schedules because time is a unit established by humans to regulate their behavior. Without this structure, Living organisms can fall into a state of chaos, leading to danger or even extinction. For humans, time has become an indispensable part of life. However, from a broader perspective, the time of the universe does not reveal such characteristics. Linear time. Science always strives to uncover the true nature of grand and abstract concepts such as time. With the current scientific understanding, most people agree that time is likely a linear dimension. Why is that? Several reasons are put forth to explain this viewpoint. Firstly, time is irreversible. Reality demonstrates that we should not believe in movies like Back to the Future, The Flash, or the science fiction novels of H.G. Wells. Time travel backward is simply implausible. As living entities, we are born, grow, and eventually perish, following that chronological order. We know about the past but cannot know the future. This is because time only moves in one direction, not in terms of perception but as a reality, according to natural science. Additionally, the second law of thermodynamics indicates that time is linear and unidirectional, as everything in our universe tends to move from an ordered state to an increasingly disordered state. A hot cup of tea will cool down rather than heat up, a dead body will decay instead of regenerating, a car will deteriorate, and humans will age. You may deny that these things are, and will happen, but someday you won't be around to deny them anymore. Ultimately, time is considered linear because we have various ways to record and measure it, and the recording and measuring can occur cumulatively. The stopwatch on our smartphones, for example, can measure time down to milliseconds. However, it would be absurd to measure everyday activities with such precision unless an athlete wants to track and push their speed limits. We can also measure time by counting the number of Earth's rotations around the sun, as humans have been doing for thousands of years. If counted in this way, time appears as a linear process, starting from a point and extending forward. Alternatively, we can measure time by observing the vibrations of cesium-133 atoms. This is how scientists establish the International Atomic Time, IAT. This global standard is so accurate that it would take 1.4 million years for it to deviate by just 1 second. These natural phenomena can be recorded in long, cumulative, and linear sequences. Cycle time. Nevertheless, there are also ideas suggesting that time has cyclical and repetitive aspects. Firstly, many commonly used time measurement systems in our daily lives are cyclical. 60 seconds make a minute, 60 minutes make an hour, 24 hours make a day, 7 days make a week, 4 weeks make a month, 3 months make a season, and 4 seasons make a year. So, isn't the sense of déjà vu that we often experience, and the repeating patterns in history evidence that time has a cyclical nature? If time truly has a linear essence, why don't we use linear methods of measuring parameters, starting from a single point and extending forward to infinity, like measuring distances? Furthermore, humans don't necessarily need linear, orderly methods to measure time. Even today, the lives of farmers, nomads, and urban dwellers are governed by an endless repeating seasonal cycle. Calendar systems originally designed to express time linearly are a relatively recent phenomenon when compared to the long existence of our species. The earliest calendars date back to 10,000 years ago, and carefully recorded calendar systems have only become widespread in the last 5,000 years. Considering that our species is 200,000 years old, this means that for at least 95% of the time humans have existed, time was something cyclical and measured by days alone. In the end, calendars are cultural and artificial constructs. Have you ever noticed that the year in the calendar or the linear time frame is counted as accumulated units from a specific starting point? This is because the calendar year is used by political and religious authorities to mark events they consider important, such as the birth of Jesus, rather than natural or scientific events or processes, such as the origin of life on Earth. What are the differences between the Jewish, Chinese, Gregorian, Christian calendar, Western calendar, or solar calendar, and Mayan calendars? Not many, considering the concepts and perspectives of time. These calendars have different origins, starting points, counting systems, and various holidays, and they are only relevant to humans, not to animals, plants, or planets. Ultimately, each calendar is nothing more than a cultural construct built upon the political, religious, scientific, and economic systems of a region, all created by humans. Human beings have a complex relationship with time. Our modern lives are almost comically structured around linear time and precise time measurements. However, our human ancestors and some of our relatives today lived with a different understanding of time, a cyclical, daily, and rhythmic understanding. This is also why time becomes the most mysterious existence. It exists, yet simultaneously does not exist. Simply by changing our perspective and reconsidering the definitions created by humans, one can discover that time does not truly exist. Before humans had intelligence, the universe was there as it always had been, independent of humanity's definitions. This is the greatest deception that not everyone understands and recognizes.
Space-time.
In 1915, Albert Einstein published the general theory of relativity, describing gravity as an inherent property of the warping of space and time. By developing this concept, he showed that time is not as absolute as we once thought, but is instead influenced by factors such as speed and gravity. Einstein revealed that time slows down in stronger gravitational fields and for objects moving at higher speeds. This idea revolutionized our understanding of time and introduced the concept of space-time, a four-dimensional fabric that combines the three dimensions of space with time as the fourth dimension. This fabric can bend and warp, creating effects that we observe as gravity. For instance, imagine a massive object, such as a star, sitting on a stretched rubber sheet, representing space-time. The star causes the sheet to warp, and if a smaller object, like a planet, is placed on the sheet, it will move along the curves of the sheet, orbiting the star due to the warping effect. Similarly, gravity can cause time to pass more slowly. This phenomenon, known as time dilation, has been confirmed through experiments, such as observing the behavior of atomic clocks on fast-moving aircraft or in strong gravitational fields. These concepts challenge our intuitive understanding of time. In the context of space-time, time is no longer a separate entity, but is intertwined with space. Events that occur in the universe are described in terms of their positions in both space and time, leading to the realization that time is a relative concept that can differ for observers depending on their motion and gravitational environment. As our understanding of time has evolved, so too have the questions it raises. Does time have a beginning and an end? What is the true nature of time at the quantum level, where the rules of classical physics break down? These are some of the mysteries that scientists continue to explore, but one thing is certain: time, whether linear or cyclical, is a profound and enigmatic force that shapes our lives and the universe in ways we are only beginning to comprehend. Conclusion: the nature of time remains one of the most elusive and intriguing aspects of our universe. Whether it is seen as a linear progression, a cyclical rhythm, or a complex fabric intertwined with space, time continues to challenge our understanding and spark our curiosity. As we delve deeper into the mysteries of time, we may uncover new insights that will forever change our perception of reality and our place within it.